Okay, I think we're live now.
Awesome.
Well, happy Friday.
Happy Friday to you as well.
Yeah. So I guess just for everyone that have already dialed in and watching the show, this, well, thanks for joining us today. This is my second time doing this, and I do plan to do this regularly. So please, any feedback or comments to improve the show, let me know. Um, So to start off, I mean, overall for this, I try to bring people, guests, to talk about data topics. I generally like diving into technical details and examples in my conversation. And, you know, Roy and I recently met, but had a pretty deep conversations about different products of AWS as well as data observability and data lineage. So thank you for joining me. Um,
Of
I
course.
guess to start off, if uh, for the any of the people that are joining here, if we haven't met before, I'm the founder CEO of SelectStar. SelectStar is a metadata platform that automatically analyzes and documents your data, so you can tell where each of your data is coming from, who's using it, what they are using it for, things like that. So you can manage and govern your data better. And uh, Thanks, Roy, for joining us.
Of
So
course.
here's Roy Hasson from Upsolver, who is the head of product and marketing, I believe, too.
Yep.
Can you give
Yeah.
us a quick introduction of yourself?
Of course. Of course. Thanks again for having me, and congrats on the second show. I'm glad I can actually be on the second show. That's pretty awesome. Yeah. So again, Roy Hasson. I'm the VP of Product and Marketing at Upsolver. Earlier this in 2023, we actually decided to merge marketing and product marketing together. It's been really awesome. Um, New space for me on the marketing side, but I'm definitely enjoying it. Upsolver is a simple to use data ingestion, data management solution that really works well at scale. Our big differentiation is scale, high volume data, streaming, all that kind of that fun stuff. So yeah, it's been doing that for a couple of years. Before that, as well, I'm sure we'll get into. I worked for AWS. I was part of the Amazon Athena team, the Glue team, and then Lake Formation, and that's kind of where I've spent a lot of time talking with customers and partners around data governance, data security, lineage, and all that fun stuff. So I'm really looking forward to this conversation.
Yeah, I think one of the things that caught my eye from your profile was this experience of working with Lake Formation, Google Catalog, and the Athena part of AWS, because that is, I would say, really the like OG of like the cloud data lake,
Yeah,
and still is the main source of like or backbone of a lot of companies' data lake, because whether you are bringing on a data warehouse or Databricks or other platforms, your actual like where all the data gets archived and dumped on, it eventually all mostly become like AWS S3 or
totally.
GCS, just more of this object storage. So yeah, curious like how you have initially seen this like um, interest, customer interest and use cases of getting data lineage and a better way to govern their data,
Sure.
since the data is also in the format that is not necessarily the tabular or structured format.
So I'll start a little bit before that, and um, you know, probably back in 2018, 2019, uh, AWS kind of recognized that people just put all their data in S3, and S3 is becoming faster and faster and faster. I worked with the Amazon EMR team, which was releasing and supporting customers who are using Apache Spark and Hive and Hadoop MapReduce on top of their data in S3, and we realized that S3 is just a fantastic place to store data, and the performance is very comparable to putting data on hard drives, right? Because if you remember, hard drives are network attached. So the round trip to the network attached hard drives is kind of similar from a latency perspective to that of S3, right? And S3 has an acceleration layer, so it actually works really well. Um, And as we start seeing more and more of that, we're also seeing users trying to query that data, right? And they have to maintain like these Hive meta stores to define the table names and the schemas and those kind of things. And we realize that there's got to be a better way to do it, right? Yes, you have the group of people and customers that are going to build with Spark and use Spark on their own clusters. That's great. But there's going to be a group of people that simply want to run a query. And if the data is already in S3, because that's where their engineers are putting the data, they don't want to go through the extra step of moving it into a warehouse like Redshift and putting a data model on top of it and all that stuff. They just simply want to query it in place. And that was the number one use case for Amazon Athena. And our users basically came in and said, like, this is what we want. We love this. This is amazing. And I still have people come to me up now and like, oh my God, I love Athena. It works so great. It's so easy. And we really love using it. And personally, I really love the service as well. And then, like, as that kind of became the norm, data lakes also became the norm. This is before Snowflake really kind of came to the market. Data lakes were all the rage. Everybody was building data lake. I remember, I think it was reInvent. I want to say, yeah, probably around 2019-ish or something. AWS announced like around 100,000, data lakes deployed on top of AWS. I may get the number a little wrong, but kind of like up there. So it was a large number of users. And like you said, a lot of them were Amazon Athena. A lot of them were using Glue at that time as a serverless Apache Spark to transfer, to process the data. And then we introduced the Glue Data Catalog, part of that family of products. And that was an intention to basically simplify the data management, the metadata management on the lake. Because like I said, traditionally it have been Hive meta stores, but that project really hasn't been fully maintained. It's kind of trugging along. There hasn't been a lot of optimizations. So like we needed to find a better way to manage metadata in a much more scalable fashion than what Hive could do. And that was really the problem that we tried to address with the Glue Data Catalog. Once we do that, right, now you have access to all the metadata. You know what's in your lake. We built the Glue crawlers that extract data from metadata, from different data files and populate the Glue catalog. So now users come in and start using that. The next step was, okay, now we have analysts querying the data. We have data engineers building data sets. We have some semblance of a catalog. People can discover stuff. Then we start getting asks from users, hey, how do I audit stuff? How do I understand the lineage of my data, how it was created? How do I understand who is accessing what? Who has permissions to what? How do I govern permissions? How do I control access to my data? Right? And that's where Lake Formation came in. And Lake Formation was basically a governance service that sat on top of the Glue Data Catalog as kind of the technical metadata layer, and allowed you to enforce column row level security, expose some more lineage information. We leverage the Glue ETL service to sort of parse users' jobs and understand kind of the relationships between the different functions or the different transformations, so we can provide them with some more lineage capability on top of that. Ultimately, Lineage was not released as a service when I was still there. I was working on it. We're trying to do something. It wasn't released yet. I don't know kind of where it went with the service because I've not been there for 2 years. But I have spent probably 2 years working with customers to really understand the use cases behind it. But the primary use case, I'd say, for Lineage was auditing. Because you had a massive data lake, you don't know who did what and what job ran and what job transformed what piece of data. Like auditing was a really big deal, especially with financial services. And then the second piece was just some kind of way to troubleshoot and debug where problems are coming from. Because majority of the challenges that we've seen with users of Athena and even Redshift is, they sort of expect a certain schema for their data. They expect a certain shape and structure, and then something changes, right? They don't know what changed. So first of all, they got to figure out what changed. Lineage was a great way to identify that. And second of all, they got to figure out who changed it. Lineage at least helped them get to the right place. Like, hey, this particular Spark job changed it. I can then go figure out what user wrote that Spark job and why did they make that change, and then I can figure out, like, what does this mean to me. So I would say those are two of the biggest use cases that we've seen, at least that I've seen while at AWS, with regards to Lineage and why it was important in the lake in particular. Nope, you're talking on mute. Yeah.
There you go. So thanks for the background. That's super helpful, I think, for everyone in the room. Overall, I guess diving into our topic, enhancing data quality with data lineage, maybe we can first define what and how data quality should be treated and how we should define data quality. How would you define data quality in today's environment?
So I think data quality really kind of, in my mind, it's two parts, right? There's sort of the company, the organizational responsibility and ownership to data quality, and then there's the technical aspects of detecting, alerting, and then fixing data quality problems. So I think, like, generally speaking, data quality is really about ensuring accurate, reliable data from source to target, right? But the important part is kind of like the organization, the producers of the data need to have some responsibility of the data they produce. Today, mostly you see data being produced and kind of thrown over the fence to the data engineers or the analytics teams, and kind of like, okay, here's the data you asked for, figure out what to do with it. If something breaks, it's on you. I don't have responsibility. And then on the technical side, you see data contracts, you see, quality expectations, you see data observability. Those are all tools, in essence, designed to solve the problem of bad quality getting thrown over the fence, right? So, like, observability, fantastic, it's great, but it's kind of like saying, like, I have garbage, I can't control it, I can't deal with it, so I might as well put some visibility on top of it so I can fix it, right? So it's two sides of the same coin.
Sure. The way that I see data quality are also kind of twofold. One is that there is a technical side of data quality to say that this data is up to date, has the right cardinality, and the all the fields are filled in. It's not like a bunch of null values. So there is usually that, you can call it a contract, but more of an expectation that the data itself is something that something that can be used, because like all the fetching job and all that has all ran correctly. I think this is where observability really comes in, because observability tools will monitor whether the row count is correct, if there is like this field has all the unique columns, if it's a reference data, things like that. I think is a good way to automatically test if the data is sound and correct. But data being sound and correct technically is not the only part of data quality, because it actually doesn't matter if the overall meaning of data is not clear to everyone. So I see another big part of data quality as the understanding and actually defining the data within organization. And I think that's what you meant by earlier, like the company support,
That's right.
right? So there is like, if even if the data is all correct and sound, and it's the like latest and greatest data, if the data is labeled wrong, or if the table does not have the right columns, then it's still not a great data, because
Right.
I maybe end up using it without understanding that the data has been already filtered by certain condition, or if this data was actually about like active users of my definition versus somebody else's definition. So the documentation, the governance, and being able to understand kind of like where the data came from is also really important for data quality.
Yeah.
So those
I,
are
I I
two
agree.
main areas that we usually
Yeah.
discuss with our customers today.
Yeah, yeah, I agree. Again, like I said, it's such a big topic. I think the challenge that we see in the industry is that most people react to data quality from the symptoms that they experience, right? So if you're commonly getting broken schemas for whatever reason, right, that's sort of your definition of data quality, and you sort of miss the rest, the bigger picture, right? Like the other stuff that you just talked about. So that's why I see, at least when I talk to people also on social media, people complaining about schema management. I got to make sure I monitor my schema changes and make sure my data is fresh. Like, okay, because those are the experiences that you've had. But have you looked sort of up the ladder, up the chain to kind of understand why that's even happening, right? So, the whole data observability thing, like, it's great. We all need it. But I also feel it's a bit like reactive to symptoms, as opposed to like, if I'd done a better job up front, would I really need all these observability capabilities? Like, I'd want it, right? You need it for your network, you need it for your tools. You always need it, right? There's value to it. But I don't think that we would have been putting as much emphasis on observability with regards to solving data quality problems. Like, I don't think
Sure.
that's the way to solve it, right? But I completely agree with everything that you said. It makes perfect sense. But most people need to kind of hear the bigger picture, like all the pieces that you just talked about, as opposed to like the technical bits. Oh, I gotta set data expectations. That's the only way to solve quality problems. Like, well, that's a
Right.
technical
Yeah, that's
implementation
not
of,
it.
of addressing it, right?
Right. Yeah, it's the full data management and organization of data and documentation that needs to also come along. So with that, what's your view of how impactful data lineage is in regards to data quality?
Yeah. So, when we talked before, before this, like I have a slightly more opinionated view of the value of Lineage, right?
Okay.
From my perspective, and I spoke to hundreds of companies when I was sort of researching Lineage as part of the Lake Formation Service, and kind of like what it means and how do we build it and what people want. I would say that a large majority, when you dig deep into what their actual need is, it's auditing, right? It always comes back to, I want to audit what happened to my data. How does this final product, how was it created, right? Who changed it, what they changed, those kind of things. And I want to be able to audit it. A lot of financial services, simply from a risk perspective, right? Like, auditors will come around and say, like, how did you create this table? Like, how'd you get this data? I need to show documentation that explains that, right? I personally may never use it, but I need it for my auditors. And you see that more and more, just because you have the risk of, the regulatory bodies like CCPA and GDPR, and much more pressure from governments to be able to provide auditing, and especially when this data goes into machine learning models that later, recommend your insurance policy or things like that. That was the big use case. When I talked to data engineers specifically, the use case that came up was troubleshooting. But then when I dug deeper into like what that actually means, there wasn't a lot of information in Lineage that was actually useful for troubleshooting. It was more of like a flag or like a pointer that says, hey, I need to go over there in this job and kind of figure out what happened. Like, who did that? Like, why was that function added? Why was that column dropped? So it was a good way to kind of point me in the right direction. The challenge was then to figure out, like, what is the best mechanism to actually provide that, because at that point catalogs were really positioned towards business users, business analysts, and folks like that. For those users, Lineage, when I spoke to them, for those users, Lineage was mostly like a nice visualization of how things were created. But in a lot of cases, those lineages are so big in large tables and in enterprises that it kind of loses some of its meaning, and you don't end up spending much time, right? Maybe if something changed, you want to go figure out how it changed. But in most cases, like, Lineage is not going to tell you, depending on implementation, of course, but Lineage by generic terms, it's not going to tell you that column revenue was derived by, multiplying column X and column Y and dividing it by column Z. Like, you're not always going to get all that detail. And that's the detail they really wanted, right? It just tells you that, those two columns combined resulted in the third column. So, and of course, that stuff can evolve and can get better. But those are kind of the primary use cases. So like catalogs who are displaying Lineage were really targeting business users, not the technical users. So it was kind of like a disconnect. Like a data engineer doesn't typically go into like business catalog to look at Lineage information, so then they can back out of that and then go into their tools and figure out how to troubleshoot stuff. So, it was a little bit of a mixed bag. The use cases weren't like super compelling, but auditing is an important aspect. Troubleshooting is an important aspect. It just troubleshooting piece needed a lot more information added to the Lineage to really be useful.
Sure. Yeah, I can see where you're coming from, also from your post. I think you mentioned kind of like the two main use cases of data lineage. I would say data lineage just overall is it's more of a like a feature, not a solution, or more of a product line rather than a design solution. And this is like twofold. One is that you have to be able to use and be able to apply data lineage for your use cases.
Right.
And that's the first thing. Like, it's not like the lineage is going to tell you where things are broken, but you can use lineage to basically troubleshoot within minutes instead of hours. I'm happy to go into it in a minute. That's like the first thing. I think there are just so many different use cases of lineage. Like, we are kind of like scratching the surface right now, because like we are like just kind of in this like phase of, oh, lineage is great, let's like use more lineage. The second part I would say also about lineage is that there like it's a solution, and there's a lot of different things you can do in combination with other things. So for example, earlier I was just talking about troubleshooting. Use case of troubleshooting is a standard use case of lineage, where you are looking at your upstream sources of the asset that is like in trouble.
Yeah.
Either the dashboard is down, the table's not great, like something is wrong. Now you have to look at the pipeline of how this table was generated, which data it was coming from, because it's probably in somewhere in the sources of the upstream of the chain. And I think the first part that lineage really helps is that instead of you having to dig into the GitHub repos and look at the SQL code or the Spark job queries or the Python code, like lineage will just tell you, okay, well, instead of you reading hundreds of lines of code, here are 5 upstream data sources all the way to the raw table, or here are all the tables that it's running from. So I think that itself already provides that map.
Right.
I think obviously that's not the only part. I think the other part that is also really important about troubleshooting is actually looking at when is the last time has this model changed from the upstream. So because like you know that this was working fine until like yesterday,
right?
So there must have been some change that has happened either in the pipeline that or some jobs. So that's where you can actually look into what changes have been made and actually debug that part.
Yeah, I just want to kind of go back to what you said and unpack it a little bit. I think we tend to use the word of the feature lineage in a very generic way that kind of solves a lot of problems. But when you dig deep into the actual implementation of lineage in different solutions, and I can't speak for the Select Star implementation, but other solutions that I've experienced, lineage is actually very bare bones. right? You kind of get a visualization of this table touch this table touch this table, this column from this column created this other column. The challenge that you have with regards to troubleshooting, like you said, like it's a great starting point. Like you can use the lineage to kind of pinpoint where the problem may be. But if, for example, I have my schema is the same, but the values inside of a particular column, now there's a drift, right? Maybe it used to be, in cents, now it's in dollars. Like without enriching the lineage with more metadata, that lineage isn't going to tell you anything happened, right? You're not going to be able to use that lineage to figure out what happened because the lineage is going to tell you everything looks good, right?
Sure, because
So
lineage is primarily for on the metadata side. Obviously, if the data value has changed and everything else looks the same, like that is not something that lineage goes into it. And I would say that is also a part where a lot of data observability tools come in because like they'll look at the sample data, like do the sampling of the data or do the profiling of the data values. So it might be actually easier to catch. The part that I think the where Lineage really helps and have been solving a lot of problems is because a phrase of how like it's harder to define a question than the answer. I
yep.
feel like it's kind of like that in data
Yeah.
troubleshooting, right? There are so many models and everybody is doing their own creation of models and pipeline. It's the part that where data engineers end up spending most time on is to actually find where the problem is, what's the root
Right.
cause of the problem. And that's where Lineage is really helping. Lineage is not going to solve that problem,
No,
but
I get
it's
it.
going to help you define the
Yeah.
problem.
But I completely agree with you. What I'm really trying to kind of clarify is that lineage is not going to help you with all types of issues. It's going to help you with very specific set of issues. So like you said, lineage is primarily focused on metadata. So like when your metadata changes, like you add a column, you drop a column, you rename a column, you add a table to a join, et cetera, et cetera. Like
Or
that
if you
type of
update
stuff.
a model. Yeah.
Yeah. So like that kind of stuff, like it's gonna help you, but that's only one part of data problems, right? And data quality problems. Like you said, like data freshness, right? When was the last time that model was updated or that table was updated or that particular column saw data? Like lineage by itself isn't going to tell you that. Like you have to enrich the lineage information with additional metadata. Like I'll give you a perfect example. So like in Upsolver, we're a data ingestion solution. So we move the data, we see exactly what happens with the data. We have data observability capabilities that kind of let you profile the data in real time and see what's there. We're working on adding lineage support inside of the tool because what we want to do is we want to actually tell you that if you have a particular table, it has a certain number of columns. The output of that table may have the same columns or some computed columns as well. But what we do is we actually enrich each of those columns with 2 bits of information. The first one is when was the first time we saw data and when was the last time we saw data? And this is per column. So for example, your upstream application had a bug and some particular column all of a sudden is not populated, right? For whatever reason, right? Lineage on its own isn't going to tell you that. It's just going to tell you that relationship exists. Cool, everything looks good. It's not going to tell you that particular column hasn't been updated in the last 10 minutes. But when we enrich that lineage information, now you look at this graph and you say, cool, everything looks good except for this one column. Why was this one column not updated in the last batch runs or in the last 10 minutes or the last hour, but everything else was? Now you have more information. I think it's really important to kind of go back to lineage and say lineage is a really good map, but unless you put road names and signs and distances and things like that, it's not going to have the power that we all think it has or that we all really want it to have, right?
I see where you're coming from because you deal with a lot more use cases around data ingestion. And for data ingestion, it is important to make sure that every data point actually do arrive at the sink,
I
right?
deal a lot with data
And
quality
that's why
problems that are hard
where
to solve. Yeah.
eventually the data quality or anything data begins from ingestion. You do need to have it in your lake or data warehouse, right? That's why I guess for you guys showing like when's the last time we saw this data, and when I am starting, like I think that bits of data for sure is very, very important. A lot of the cases that we see as SelectStar, because we deal with a lot of analytics team that are all the way at the end of the data transformation and reporting tables. I would say the data lineage is primarily for them, and also a lot of data engineers supporting these data analysts are more for maintaining the data quality of transformations that happens after the data arrives in the data lake or data warehouse. So this already assumes that the ingestion was great. And now it's all about transforming that data to be in a more usable format for BI tools and other tables and analysts. And that is the part where I would say that a lot of changes happen.
So maybe it'll be helpful if you can share a little bit about kind of like what are the information, or what are the bits of information that maybe like the SelectStar lineage feature has. I think that would help, because we're kind of coming at it from two different angles. You're looking at it from the perspective of the end user, the business user. I'm looking at it from the perspective of like, this is a data engineer who's taking a bunch of data that maybe they don't own, maybe they know nothing about, and is pushing it to a target that they're responsible for, right?
Yeah, or for you, it's actually like the production engineers. It could be data engineers too, but
it could be a software engineer. Yeah,
data,
exactly.
Right? Yeah, exactly. That all their job is they have a new, like a product launch or a new experiment they want to run. They decide to add these fields and columns or fetch this new data, and they are now putting that into the lake or the data warehouse. And that is a part where I would say there's some data engineering involved, but I think more so a lot of software engineers and production engineers are involved. The part where we come from is actually once the data arrives, where does it go? To all the way to the end users, because actually 70% of SelectStar users are data engineers and data analysts. So actually data platform teams and data engineers are our core bread and butter users whenever they are doing data migration, data remodeling, and also enhancing data quality. So
I think it would help. I think it would help if we can. Yeah, sorry. I think it would help if we can kind of break down data lineage, because we keep talking about data lineage at a super high level as the word, right? And then I think we're kind of overlapping on some of the features, or assuming certain capabilities don't exist. So in the lineages that I've built and that I've seen, they did not have sufficient information to be able to really get to the root cause or really understand the problem. They're more of like a pointer, like, here, it's over there, go deal with it. I think SelectStar may have some additional feature. I think it'll be really awesome maybe if you can kind of break down and like what does lineage mean to you, and like what are some of the key capabilities or key bits of information that your lineage provides, and maybe that will help kind of align on how these are solved. Because I think the problem is missing the actual data specific information to really tell you is data drifting. Lineage, in my opinion, is mostly schema related drifts, right?
Yes, it is. It is all about schema. I guess to define what data lineage is, it is I would consider this as a map that shares the data assets, dependencies, and it like kind of like its children. So it shows where and how the data has been created, and then because you will be able to understand all the sources of each data by connecting them together as a form of lineage, you're going to get a graph or a tree-like view that shows all the dependency chain of every table and column.
Yep.
So with that, let me see if I can do a quick share.
Yeah, that'll be awesome.
So I have a quick share here, which shows like the SelectStar lineage. So here I have a Looker dashboard that so it's if you were to start from like end user perspective of BI analyst or data analyst looking at a dashboard, trying to understand where did that data come from? How did we calculate total order value? How did it get summed up? They can look at where the data came from, which is coming from this user looker explorer, this specific field. And this specific field was derived from a looker view, lookml view, which actually came from like order items table in Snowflake. So
Is there a way that you can see the actual calculation?
yes, and for us, yes, because we will show also the SQL. If you click on more into the table itself.
So that's
So for
that's
us,
an
the
important
way,
that's a really important point, right? Because what you talked about here is lineage plus dependency, but the issue is when I'm trying to troubleshoot something, the dependencies are not as important to me. It just kind of says like, go look at that table over there. But ultimately, first of all, I gotta detect that there's data drift, right? That calculation is wrong now because for some reason somebody screwed it up. Now the number is wrong. That's the problem I'm trying to solve. The dependency or
yeah.
the
So
lineage allows me to get to the source table where the actual SQL transformation happened. Then I need to be able to see the transformation, understand it, and realize, hey, last week it was X, this week it's Y. That's the broken part, right? And that's kind of
yeah,
the piece I'm talking about, where lineage on its own is a good pointer to where to start your analysis. But unless you can enrich it or provide more information like you're doing by pointing me to the SQL, it's much harder. There's a lot more to do for a
yeah,
data engineer
yeah.
to troubleshoot the
We
problem.
because we generate every lineage from the main like DDL DML queries.
Mhm.
Like we will keep track of all the history of that so that
Yeah,
you can see what it used to be and what it's now.
right.
But it is really to minimize the time to find where the problem is, and I would say that's where the troubleshooting really come in. Now the other use case that you mentioned, which was auditing, there has also been some questions about lineage, using lineage for to satisfy regulatory requirements, or things like compliance. And so let's talk about that a little bit. I would
Sure.
say that auditing perspective, um, it actually is kind of like we just talked about this whole how the lineage can be traced upstream to do the troubleshooting.
Mhm.
For auditing and regulatory side, it's actually all about downstream, looking at the lineage from the downstream, from the raw table or raw file, all the way down to wherever the data has been presented. Because that's where all the data is being touched upon or being utilized upon. Um, and the part that we see a lot, there are two things that we see a lot on regarding regulatory requirements and compliance side. Uh, Depending on the industry that the customers are in, and there with all the new regulations coming out, one of the things that a lot of customers wants to track is who has accessed this data. And hence companies like Snowflake, they now have a feature called the access history that
Mhm.
just gives you kind of every single query, like it will list the tables and columns that's been touched.
Right.
In a way, I think this is where the also understanding the queries, like a select queries, like what does it touch, is come from. But then, where does the lineage really touch this upon? I would say there are two things. One is uh, because once the data is collected and ingested, and if you've already marked some of these fields as sensitive columns or classified data, you can trace through lineage downstream to understand which tables and data assets that are utilizing that data. So it also shows kind of like the other way of the map of the impact,
Yeah.
or the part where where it's affected with the classified data. The part that is quite important here, which also applies to a lot of regulation and compliance perspective, is how that data has been, utilized. So this is actually one of the, I would say, more like a differentiating features of Select Star that we have in our lineage, which is understanding the column usage. You push the data set, and now you have some sensitive or classified data. When we show the lineage in the column perspective, we will display whether this table or whether this column, whether this column has been utilized as is, or whether there was a transformation like anonymization, or whether that could be a aggregation of that data that has happened. So from there, once the data is aggregated, transformed, or is not being utilized, is it still important for us to say this is where it goes? No, because now you've satisfied some of the requirements and you may not have to trace all the way downstream. And I think this is an important distinction to make when you're trying to use Lineage for complying with regulatory requirements automatically.
Yeah, so
Any
I
thoughts on
think
that?
yeah, makes a lot of sense. I think you kind of touched a lot of different aspects of it. I think typically regulatory requirements are around access controls, which related to PII, PHI data. I got it's not really regulatory related. It's more of like security related and internal privacy kind of auditing, where you want to figure out who has access to what. If there's a particular table that may have some sensitive columns in it and Roy doesn't have permission to those, got to make sure that he doesn't actually use those columns. Like security is actually set up correctly. So I think from a security compliance, privacy compliance, that's one big aspect of it. The regulatory compliance is really about, we need to, the government or the regulatory body needs to understand how data is created and how it affects the outcome, right? Because many times we make decisions, whether those are manual decisions by humans or those are automated decisions by machines or ML. Regulatory bodies want to understand what data fed those decisions and why did you make those decisions? Because if a company is making a decision whether to give me an insurance policy and they make certain decisions based on race, gender, things like that, or some kind of bias, then that's a problem, right? So they want to be able to understand how you're making those decisions, right? And it's extremely critical now with ML and Gen AI, where data goes into this black box and decisions are made and people are maybe discriminated against. That's not okay, right? We want to be able to identify those things. So Lineage is really good at solving that problem because it shows you, like you explained, how is data derived? Where did it start? What points in the chain did it change? How it changed? What changed? And then how it's being consumed? Are you collecting it from a model? Are you collecting it from an analytics dashboard? Is this affecting your marketing campaigns? Is this affecting your sales campaign? Is this affecting your application? Like that's all very important information that Lineage can expose for regulatory purposes. I think what you said about the access controls, currently, from what I've seen, and maybe Select Star is a little bit different, access controls aren't typically overlaid on top of Lineage, right? The traditional Lineage, it's more of like the dependencies that you talked about. Now, it's awesome that Select Star is doing it. I think more companies should be doing it, where you're actually showing me, like, here is the table, here are the columns, these are PII columns, these should be locked. Now, how do you overlay different users' permission sets on top of that? It's a slightly different conversation that we can have.
I'll tell you that.
But it's really powerful way to
Yeah.
do that. Yeah.
Yeah. I mean, this is why, we've seen so many different cases of Lineage from Select Star, but we're also continuing to see more and different applications of this, which is really amazing. I think I do want to point out that you bring up a good point. Like the part that I talk about is more of the security side of the compliance. Whereas regulatory requirements of compliance does actually start from data collection. According to GDPR, you do have to specify purpose of every single data that you're collecting. What is it for? Like, where are you going to use it? Like, hence, like, do you really need that information? And you have to now categorize them all. And I think that is also an important part that starts from the data ingestion side of, because you've now decided to use a cookie or whatever to collect this data. You have to specify and publish what you're using the data for. But now the data has been arrived, that now you have decided to collect it, and you've said that you will, and you got your users to accept the terms and policies and privacy policy. Now about the security side and the access control side, I think it usually comes in two steps. First and foremost, defining all the data sets that has to be classified. So this is the part that I mentioned about using Lineage to automatically classify all the columns based on the raw data that you might have collected that should be treated sensitively. The other part is actually just define, even before then, you may also want to define very specific columns as a classified data, because it is a classified information within your company. So today, SelectStar and other platforms do support ways to manually put like some regex rules and define columns, or using a lot of tags, right?
Exactly.
So that in companies like like there are a lot of data privacy companies that will like sample data, and their AI will detect, or machine learning will detect that, oh, this like should be classified.
We did a lot of that with lake formation. Yeah.
There you go. Yeah. So if you want to comply with GDPR, ISO SOX compliance, like these should be detected, right? Because for a lot of industries, they also collect so much data from like handwritten forms, and they've converted a lot of these unstructured data into, and when they're putting it into a data warehouse, they do need to be aware of those, and not a person or data engineer cannot go back and then do everything. So I think there are a lot of options on the data privacy side on classifying data. Now, the other part is the access control. So, but I see this as like two independent pillars, because there can always be many different types of data sources that keeps coming in. But for the data governance and security perspective, you will have your own map of what type of roles have default access to what data, and which should be the like more classified or restricted access data assets. And the way that I see this working really well is to implement both sides, but to marry them by through another mechanism, like almost like a use tagging as an interface between them.
Yep.
So anything that's tagged as a certain level of PII, those are by default no access, or those are by default up to this level of role can have access.
Yeah, and that's typically referred to like as ABAC, like attribute-based access controls, right? Where that's kind of exactly what you do, right? You tag certain resources with a certain or attributes of columns or things like that, and then you define policies based on that. So like by default, when anybody joins a company, they get access to all the popular tables, but within those tables, there are specific columns tagged or as PII, and by default, nobody, you don't get access to that until you join a certain group that has those permissions, right?
In a way, I actually like the word that you used as policy, because we call it a policy-based access control. You do need both, in a way, attribute and the role, like role that defines different permissions to be applied to a user or team or a group of things, but the assets that it goes into should also have, based on some attributes.
Yeah, absolutely. It's two sides of the same coin, right? Like the attribute sort of defines what are the things that you need to control, and then the role defines the user and their entitlements, like the things that they are allowed to do, and then you sort of marry the two. I think ultimately when we go back to Lineage, like Lineage is a really good visualization. Like Lineage on itself, like it's not the thing that does the work, right? It's like a map, right? So like the more things you layer on this map, the better the picture becomes of your data landscape. And I think that's, in
Yeah,
my mind, that's
exactly.
the important thing that we need to kind of communicate to people, is that you're taking this bare bone maps that only has a bunch of lines on it, and now we're layering all this extra goodness on top of that, that when you open it up and look at it, it's like, oh my God, everything I need to know is here. And that's the powerful thing. That's why when I talk to like catalog companies, I say like, look, Upsolver is ingesting a lot of data. We have so much information about this. Like, I'm not a catalog. Like, I don't want to be a catalog. I don't want to be a Lineage service. I want to give you this information so you can enrich your Lineage and your catalog. So when a user clicks on that table or that
That,
dashboard, it lights up with all
it,
this extra stuff. And that's the
yeah.
important part of Lineage. And that's why I think Lineage is exciting. But I think when you talk to people in general about Lineage, it's sort of they miss what is available today, and they sort of layer a lot of like, oh my God, I really wish I could do those things. But even though Lineage isn't there for that, right? It's not there yet.
It's
It's awesome
almost
to see
like
Select start doing extra things on it.
yeah, because it's almost like, 5 to 10 years ago, Google Maps only showed directions from where to go from one place to another.
Yeah.
Now Google Maps shows you all the restaurants and then the reviews and like,
Police cars on the
you can do
road.
like a
Yeah.
nearby search. Yeah, traffic, like, there's
Yeah.
just so like, or there's an accident down the road. Like a lot of that, I think is kind of like an analogy or like things that we're
Right.
also starting to see
That's
on
the
Lineage.
future of
I mean, this
Lineage.
is like
Yeah.
where, yeah, this is like,
Yeah.
because we see so much of this application of Lineage with something like this, like, regulatory is a big thing. And even for access control, like
Yeah.
to, uh, because like you will propagate the classification, you can actually use that automation for your policies
Right. I mean,
because
look,
of the tags are already propagated, right? Uh,
yeah.
so I think that's like one big way where it actually lifts a lot of manual work out
Yeah.
of the governance teams.
Look, Lineage is a really good visual tool. It's a visual aid, right? It's really quick and easy to kind of skim through and understand in quick, in a very short amount of time, like a big problem. I think like over time we need to also think about, and I'm not in that space right now, so I'm not really thinking about that. But ultimately, the challenge that we ran into with Lineage at Lake Formation and AWS, and we talked about it with customers, is the scale. Right? We had customers with hundreds of thousands of tables. We had people with like petabytes of data. Worked with financial companies and healthcare companies that had, thousands of tables, and each table had 3, 4, 5,000 columns in it. Right? Whether you need all of them or not is a different question. But such massive data sets that Lineage, when you look at it, it looks like a big black box because the lines just overlap with each other. So, you know, I'm not saying I'm saying it's something that we need to think about. I haven't really spent time thinking about that, but like, how do you, fast forward 5 years from now when you got data everywhere? We got lots and lots of tables, LLM models that are pulling terabytes and terabytes of data a day, and we're changing stuff all the time. Like, what does Lineage look in that scenario when you get to that really massive scale? How does it remain relevant, or how does it remain usable when you have 10,000 columns, when you have 5,000
Yeah, I
columns
mean,
across hundreds of thousands of tables?
between us product people, there's a lot of really exciting ways that we are iterating on Lineage. But scale is something that I've spent a lot of time on last year because we are working with one of our customers, Blog, who owns Square. We have a case study about it because they were specifically looking for a Lineage solution that scales.
Mm-hmm.
And when we
It's
ran
always
our
hard.
Lineage,
Yeah.
their production environment, we ended up, we were managing more than 42 million Lineage nodes and edges for them. And this is coming from like more than 600,000 tables. And if you can think about like the number of columns that they have from those 600,000
Right.
tables, it's massive.
Yeah.
So I think there are two parts on the lineage scale. One is the overall processing of lineage, like being able to actually keep it up to date with
Right.
all the queries that come through is one part, but it's a technical problem that needs to scale, right? The other part is the user experience. How to make
Exactly.
sure that, when you're looking for and you're trying to solve something, you can actually adjust or understand the lineage in like quickly, and also without getting so confused if you have
Yeah.
so many nodes, right?
That's
So
a harder problem to
overall,
solve.
yeah, it is. It
Yeah.
is. So I think just like quickly, some of the things that we added were things like being able to see lineage, not just based on the graph view. So graph view is like kind of like the tree view that everyone is very
Yeah.
familiar with. But we also have a list view of lineage that you can basically keep opening or closing based on the branches that you want to go down, and actually having a filtering and search that's embedded in, so
Yeah.
that you can actually see from all your downstream, like which are the tables that includes a certain keyword, or this is a certain type of data asset. So you can see like all the dashboards versus just the tables. So these are some of the small controls that really helps navigating the lineage, or even like filtering by tags,
Right.
because when you have like literally 50,000 um, downstream objects,
Yeah.
uh, you don't want to see all that. I mean, it's just not relevant anymore.
No, it's
So
not. It's not realistic. Just
the
yeah.
way that we think about it is how to summarize it as much as we can. So showing a lot of counts, and then also help users to find uh, to find what they're looking for as quickly as they can. And
Yeah.
this like list view of lineage have been really beneficial, because it also like loads much quickly. It's not like a
Right.
lot of like visual. You kind of focus on what's important.
You focus on the
Um,
value, not on
yeah,
the visual snazziness of it. Yeah.
yeah, yeah.
Yeah. I mean,
But I
honestly, like
think scaling
yeah. Go ahead. Sorry.
and yeah, the scaling, and there's like so much on lineage, and just like what you mentioned, like I love that analogy of like maps, uh that we are adding so much more metadata on top, and I think that is where you make lineage a lot more attractive. So
Exactly.
yeah, I'm actually excited to like continue make our lineage better with things like metadata that we can get from data ingestion platform like Upsolver. So because that's like where the data quality begins,
Yeah.
and um, also classification can begin.
Maybe
Um,
maybe this is a budding partnership. I'm actually very excited to hear that.
yeah,
Um,
I really think that there is a lot of like synergy that can be created
yeah.
as we start branching out to more of the source systems
Yeah.
for lineage as well.
Absolutely. And look, hopefully I didn't come across as a hater of Lineage. I don't hate it at all. I think it's fantastic. I think I think
Yeah,
as people, like,
like
we tend to sort of like see an idea, and we kind of put our hopes and dreams on top of that idea, and then like it can really do this, it can really do this, but in reality it can't do any of that stuff that you talk about. But then over time we build up, right? And I think Selectstar has done a really good job at kind of building up on top of that idea of a lineage, kind of realizing like it's a really good starting point, but if I put this extra things on top, this extra metadata, it becomes so much more powerful. So like I think the lineage graph, the visualization, the early map is the V1 of lineage. Right? V2 is when you start enriching it with a lot of metadata. I think V3 is where you start bringing in things like Gen AI, like co-pilots. Like nobody wants to traverse through like a massive graph with 50,000 nodes. Like that's not realistic. List table is great. It's a good start. I can search, I can filter. What's the next thing? Like, hey, find me the problem, or find me, the column that does not have data, or, that's where things start to become really, really exciting around Lineage. And I think the more pieces we add to Lineage, the more powerful it becomes. And it's no longer just auditing and just troubleshooting. It's like, it's kind of like the heartbeat of your data platform, right? It become more
great.
important. Honestly, like it can become bigger than a catalog, right? Because ultimately it kind of is a catalog, right? Um, you put the same metadata. So I think it's the marriage between catalog and lineage and metadata. In my opinion, that's the future. That's going to be the really, really cool stuff.
Awesome. Well,
It sounds like
Roy,
you're in the
thanks
middle
so
of
much
it.
for
So,
joining me today.
of
I
course.
like your summary. I think you put it well. I think I'm very excited about the future of Lineage and all the things that we can do more with Lineage going forward. So thanks so much for joining me today.
Absolutely. My
I think
pleasure.
for anyone that's still here, feel free to leave comments and questions so we can answer. We didn't have enough time today, but yeah, we can definitely answer on the LinkedIn page. And yeah, I plan to do this every other week, so please stay tuned. And
Thank
thanks
you,
again,
Shinji.
Roy.
Thanks for having me. Appreciate it.
All right, bye bye.
Bye.